Hello there, class. I hope everyone's well. Today I'm going to be showing you guys how to use the U-sub technique when you are integrating. So let's start off with a very easy example. The integral I here is equal to 3 plus 2, so the root of the argument 3 plus 2x, dx. Now, if you guys are familiar with integrating, I hope, at this point, you'll know that this can't be solved with just a straightforward formula. We know one of the formulas, especially the one with a function that's to the power of something else. Typically, you'll have it under this way. So you'll have an integral that's like this. So you'll have like x to the r dx. And that will give you something like x to the r plus 1 over r plus 1 plus c. Basically, you raise the degree of the exponent in the numerator, divide it by the same exponent that you raised to the degree again. So you're always raising it by 1. So hypothetically, if you had x to the 2 dx, this will be equal to x to the 2 plus 1 over 2 plus 1 plus c. So it would just be equal to x to the 3 over 3 plus c, right? So this is easy, you guys know this, but this doesn't give us something that we can solve very easily when we use this example right here. There is a technique to solve these. We call them U-sub, and all it is you're using u as your new variable in your argument to easily solve this problem, to bring yourself back to a very easy case that you can just apply the formula in the first place. So enough talking, let's get to work. We're going to say u, or any variable. You can use z, you can use y, but typically we use u in the calculus textbooks. So u is equal to 3 plus 2x. Basically, I'm going to ask you guys just to trust me here in the beginning. I'm going to tell you, take the derivative of u, so du, the derivative of u, is equal to the derivative of the x side, so this side as well. So we know the derivative of 3 is just 0. We know the derivative of 2x is just 2. So we say plus 2, this whole thing times dx, right? So we can say that du is equal to 2 dx. And we can say that du over 2 is equal to dx. The benefit to doing this is that we're replacing u as our argument here, and we can see that the dx that we have in our formula originally, right here, gets replaced with the du over 2, right? So if we were to continue our integral up here, we can say that the integral of 3 plus 2x under a root will be equal to the root of u, because u is equal to this, right? That's the whole point of what we did over here. This whole thing is times du over 2. It's implicit right here. We never really write it, but it's known that there is a multiplication between this factor, 3 plus 2x under the root, and the dx. We don't write it, but just understand that this is a multiplication between these two things right here. We know that you can take any constant out of an integral. So we say, well, 1 over 2 multiplies the integral of the square root of u du. Remember, the square root is equal to what? The square root is just u to the 1/2 du, meaning that this brings us to one of our base forms that we know super well. So the power rule, so we'll just use 1 over 2 times u to the 1 over 2 plus 1 over 1 over 2 plus 1 plus c, because it's the constant of integration. This is important to write after using any indefinite integral. Right? So if we develop the top and the bottom, we'll have something like u is equal to 1 over 2. Sorry, I meant to say 1 over 2 times u to the 3 over 2, because 1 over 2 plus 1 is 1 over 2 plus 2 over 2, 3 over 2, over 3 over 2 at the bottom again, plus c. easily right here we can cross these two out because they simplify, which will leave us with something like u to the 3 over 2 over 3 plus c. Now we can't leave our answer just like this because the question in the beginning, the integral, was in the form of dx. Right, so we kind of want to find our answer under x. So what we do is that we know that u is equal to 3 plus 2x. So very easily, wherever our u is, we replace it with 3 plus 2x. So 3 plus 2x to the 3 over 2 over 3 plus c is our final answer. You can leave it like this, or you can also write it under this form right here. 3 plus 2x, this thing right here, to the 3 over 3 plus c. So that's our final answer to the integral that we just solved right here. Thank you and have a nice day.